Do you use inquiry in your math classroom? Perhaps you should be. We're going to talk about how you can use inquiry pedagogies in your math classroom to build a better math class. Thank you for joining me. My name is Patty, and I am a teacher here in Ontario, Canada. And every week we have a new episode of Teaching with Madly Learning that comes to you to talk all about teaching in the junior grades, whether it's inquiry-based learning, differentiation, or all things subject related. We are here to help make teaching and learning more fun for you and your students. So we're going to talk about inquiry-based pedagogies and how they can be applied in your math class. So number one, I want you to answer these questions and reflect on your last week or two, perhaps, in teaching math. Was your math program student-centered? Did your math program harness your students' choice and voice? Did you support your students in learning differently based on their strengths and needs as learners? And were your tasks open-ended that allowed for the widest variety of students in your class to access the learning? We're going to go through all of those and give you some ideas on how you can have more inquiry-based pedagogies in your classroom. To start, we're going to look at student-centered. We want our classroom, if we're using inquiry-based pedagogies, we want our classroom to be student-centered, which means that the decision that drives our planning, that drives our tasks that we use in our classroom to be based on student need and student readiness, and not simply on a checklist designed by the curriculum as something we need to cover. If we are planning without the students in mind and what they need as learners, and we're simply just planning a lesson to meet a specific expectation only, then we are missing the point of teaching, where we are delivering content to our students and making sure that we're focusing on their needs as learners and how we can get those learners to meet the expectations. In order to do this, we need to understand our students' strengths as well as their needs and perhaps any gaps that may need to be filled. And over the last year and a half, there might be a few gaps that we need to address. Understanding that especially in math, that we need to help to build those gaps and to fill those gaps so that they can move on to understanding concepts is really key in their success in our math classrooms. We also need to look at the questions that we're asking and making sure that the questions we ask in math are relevant and practical for their daily lives. We don't just want math in our classrooms to be something they do, but we want it to be linked to the real world and real practical applications of how math is used in everyday life. We also need to remember that all of the strategies we use should be good for some, but they're also going to be great for all of our students. Things like using manipulatives, open-ended tasks, simplifying instructions, using multiple strategies to solve different problems are all going to be really important in a student-centered classroom because we want to make it accessible for the widest variety of our learners. Now, in our math classroom, the type of tasks we choose are also going to be important. These are going to include open-ended tasks that allow our students multiple entry points. It means that regardless of where the student is starting, there is something they can do in that problem that uses math to be able to solve it. Whether they are solving a problem or a word problem using repeated addition, they're modeling it with manipulatives, they're using multiplication, or even more complex ideas where they're getting into different concepts. We want our students to be able to access and contribute to their group or to the whole group in their ability to complete the task. One of my favorite ways to help students do this is through number talks or number strings, as well as through numberless word problems. These are all really great strategies that help students to think more openly about tasks. We want to address with students that there's more than one way to solve a math problem and that math isn't always as black and white as we think it is, or as we've convinced ourselves it being. There's not always a right answer and a wrong answer, but in math, there's lots of gray area. And we can teach students that there's more than one way to do things and that we can honor their own strengths and needs as learners to understand how they can solve different problems. We want our students to be able to explore different concepts in practical ways and be able to apply different strategies that they use to real-world examples. We want to tie in the different components of the curriculum together so that they make sense in a logical way. We don't only want to teach addition once and then never teach addition again. Addition, subtraction, multiplication, division come up over and over, whether we're talking about location and movement, coding, financial literacy, or calculating the area and perimeter of different three-dimensional objects. We want to be able to tie in the different strands of math curriculum to each other so that we can see how well math is interrelated and practical in its regular everyday usage. Creating open-ended spiral math tasks as culminating activities are a great way to do this. Think about everyday real-world examples that your students would need to solve in order to be able to function in everyday life. Things like going to the grocery store, planning a party, planning a soccer game, or going on vacation, having a bake sale at school. All of these require multiple strands of math in order to be able to solve. And giving students real-world examples and practical ways that they can apply what they have learned to be able to solve real-world math tasks is a great way to have students understand how math is related to everyday life. Now, another area that we really want to embrace inquiry pedagogies in our math classroom is choice and voice. We want to be able to listen to our students, listen to their interests, but also be able to give them choice. Instead of having one or two questions that they need to solve, and everyone has to do the same, providing them multiple ways in order to solve. They can choose different questions in order to solve the problem or demonstrate. Understanding the difference between practice tasks and assessment tasks, and recognizing that not all students will need to do the same amount of practice tasks to gain mastery, and that practice tasks are simply just tasks. Allowing our students to decide how many practice questions they need to do in order to be able to show mastery is a great way to build in more choice and autonomy. Certainly, we're going to have some students that will do one or two questions and then try to show mastery and they're not quite there yet. Getting them to understand that they have the ability and the control in order to decide when mastery is being accomplished and to own the results of their hard work is a really important lesson for students to learn. Not all students are going to have to do the exact same amount of practice in order to be able to master different concepts. And getting students to recognize this is an important skill too. Giving our students a textbook page of questions and asking them to do all of them is going to be required for some in order to gain mastery, whereas others will only need to do a couple of questions. Allowing that flexibility in your classroom to get students to determine when mastery has been accomplished is a really good skill. It also takes a little bit of nuance here from the teacher to be able to support students through this growing phase as they're beginning to recognize when they're done. Now, in a math classroom, really think and evaluate when you're using choice and voice, it matters who is doing most of the talking. Think about your typical math lesson. About how many minutes of a typical math lesson are you spent doing most of the talking? Are you talking the majority of the time? Is there a way for you to reduce the amount that you talk and increase the amount your students talk? The saying goes that those that are doing the talking are doing the learning. So if you're the one doing most of the talking, it means your students aren't really doing most of the learning. Getting them to do more of the talking, getting them to be engaged and active in their learning is going to be a key focus when you're transitioning from a traditional based classroom into a more inquiry based math room. One of the ways I like to do this is to not start the lesson with a lesson. I like to put my teacher-directed lesson or the teacher-led portion of the learning at the end of the lesson. It's not where I like to start with. I like to start with students working, students engaged in the problem, but not have the teacher do all of the work in the front. Get students to do some of the work, have them struggle through the concept, and then talk about it. Do some bringing up of the learning, get them to address different concepts, but this is going to be a key important component of the learning. We also want to allow our students to choose the method that they are going to use to solve the problem. There is a reason in our math classrooms that we teach multiple methods on how to add, subtract, multiply, divide. We want to show our students multiple ways of solving problems, and then we want them to be able to choose the strategy that they are ready to use at the time. Now, we should be teaching them as well that there's a reason we have a progression. There's a reason that we don't count by ones when we're adding larger numbers because it is inefficient. Certainly some students might still be there, but as we get better and stronger as mathematicians, we want to move our students to finding more and more efficient strategies so that they can solve more complex problems faster. But recognizing that students are probably coming to us at a multiple different ability levels, understanding that they're not all going to be ready to jump straight into, say, a standard algorithm, which is often a super efficient strategy to solve math on pencil and paper, that we want to also give students the opportunity to use alternate strategies because that might be what makes sense to them at the time, and giving them the space and the room to be able to solve those problems at their own pace. Once they get comfortable with one method, we can then begin to show them and transition them into using perhaps more efficient methods of solving problems. In order to have inquiry in your math classroom, there is some fundamental beliefs that you are going to have to support your students through. Number one, all students can be good at math. Sometimes we have students that have a misconception that because they are not good at the traditional definition of what it means to be good at math, then they must not be very good at math. So it's just something they have to get through, and it's not something they can do successfully. This is a belief we have to challenge because it's going to be imperative to our students' success in an inquiry classroom, because we simply don't just want them to fall down and flounder because we're not holding their hand and doing a lot of the work for them. We want them to understand their strengths and needs as learners, and understanding that it's difficult for them to compare themselves to other students because every student has strengths and weaknesses in different areas, but that math has enough flexibility in it that you can use your strengths to be able to complete math tasks, and that just because you can't do it as fast or as quick as somebody else does not mean that you're not good at math. Being good at math is not about being great at memorizing or great at automatic recall. But that's a function of your memory, not your ability to do math. So getting students to recognize that there's multiple ways to be successful at math, and that they can recognize their strengths, their ways of learning, and how they can harness those strengths to apply it to be good at math is a really important skill to be supporting students in during their journey, so that they can dispel some of those myths that just because perhaps their memory is not as strong as others does not mean that they can't do math. We also need to encourage students that mistakes are expected and supported. We know that in math, mistakes are inevitable, but getting students to not come down on themselves so hard because they made a mistake is okay. Math has lots of mistakes, just like science, and getting students to recognize that part of the journey is to make a mistake is going to be really important. The other aspect is the struggle. We need to start teaching students what learning hard things feels like, and that inside your body there's ounces of frustration and wanting your body to fly away and leave the situation because it is hard. That is a natural response to the struggle that happens when we're learning new and difficult concepts. When students recognize this reaction to hard work, it is important that we get them to recognize it and give them the tools and the strategies to help help them overcome these feelings. In an inquiry-based classroom, they will struggle and they will fail. Our job as teachers is to support them through this learning, not to pull them out of the fire, but to show them where the ladder is. Now, we want to be able to show them that this is what learning feels like so that when it happens, they recognize it and they have the strategies to push through those feelings, and understanding that learning sometimes feels really uncomfortable. And it's okay to live in that uncomfortable feeling and to tell themselves that they can do hard things and they can move past this feeling of frustration. Finally, in our math classroom, because we are wanting to use more inquiry-based learning and we're using student voice and choice and allowing our students to be autonomous, it means we're going to have more opportunities for differentiation in our classrooms. Asking yourselves when you're planning a task whether or not students have access to this question. Are there multiple entry points? Can a student who is working at a grade 2 level, a student that is working at a grade 4 level, and a student that is working at a grade 6 level, can they use a strategy or access this question successfully? Is there a way that you can simplify one aspect of the question that allows them to be more successful? So if you're asking a question about how many chairs you are putting out for an assembly in the gym, and you're putting them in rows and columns, and you're putting them out in the gym, can you simply change the number of total chairs that you have to put out in the gym to make the question more simple or complex? When writing out that question, could you write out that question and put a blank space where the number goes and allow students to choose their own number that goes in that blank space? Mr. Smith is putting out blank chairs for today's assembly. If he arranges these chairs in rows and columns, how many chairs will be in each row? We don't tell students how many chairs are in the row, but we allow them to choose how many chairs are in the row, and we give students guidelines. We say if you are struggling, so we talk about their self-assessment for where their math is. If they think they are getting strong and want an extra challenge, we tell them to choose a 3-digit number. If we want students to do good work and they're feeling comfortable but not overly confident, maybe we want them to choose a number that is a 2-digit number between 50 and 100. Perhaps if we have students that are feeling not so confident, they're not quite getting it, we guide them to choose a number that is between 20 and 50. And for our students that are struggling a little bit more, we allow them to choose a number below 20 and encourage them to use manipulatives in order to show their thinking for this question. When you're creating this question, it means that every single student gets the same question. The only thing that changes is the number that your students choose for the number of chairs in the question. Every student works on the same question. Strategies might be the same depending on the numbers. Students can share. Every student in your class could potentially choose a different number. You might have some students picking 999. Because it's the highest 3-digit number that they can choose, whereas other students might choose 18. Both students are going to probably use similar strategies to decide which number of chairs, rows, and columns and how that looks, but each student is going to pick a number based on where they happen to be. And we can change this and apply this concept to lots of different questions in our math classroom. It means that students get to choose the number, they self-assess where they happen to be, they have some autonomy to decide their strengths and confidence in the math, and it is our job as teachers to monitor what numbers they choose, encourage them to choose perhaps different numbers the next time, and build that confidence, have them practice with lower numbers as they move forward and choose bigger numbers later. But we can differentiate and allow multiple students to access the exact same question at their own comfort level. Another thing that I think we definitely need to encourage when we're differentiating is we need to design tasks where every single student in our classroom is required to use manipulatives for something. We demystify the judgment that happens when students use manipulatives. We make manipulatives just a thing we use as a way to demonstrate our learning for every single student, not just for the students who are weaker in math. And we also demystify the use of calculators and accept that calculators, again, are not just for students that are struggling with math, but that calculators can be used for a variety of different situations. There's no fault that any of us have in using a calculator. In fact, I bet you in the past month, you've probably opened the calculator app on your phone multiple times to do simple calculations that you would maybe not expect your students to do in your classroom. However, using a calculator is the reality that we are using calculators in our life to help us solve math problems. Now, do we always want to have students using calculators for every single task? No, but there are times and places where calculators are perfectly acceptable to use for all of our students. And it helps us to demystify the use of calculators for students who really do need to use them. We allow manipulatives and calculators for all because it really helps to aid those students where calculators are a necessary tool in order for success to be achieved. When we're using inquiry in math, we are keeping our math class focused on a student-centered place to be. We're focusing on teaching the students that are in our classrooms and meeting their needs wherever they happen to be and helping them to move to the next logical step. We are increasing choice and voice in our activities and in the tasks that we're creating for our students to allow them to grow and change and learn within our math classrooms, while also respecting their ability to choose when it is they are able to take on different challenges. We also want to increase our students' confidence in math and let them grow as learners and understand their strengths and needs as learners and how that fits into our math program. And finally, we want to make sure that our tasks are open-ended and differentiated so that multiple students can access the learning in ways that are responsive and reflective of their needs as learners. I hope that in today's episode, we've given you some ideas on how you can use inquiry-based pedagogies in your math class to make learning more accessible and fun for you and your students. Thank you so much for joining me, and we will see you next week for another episode of Teaching with Madly Learning. Bye for now.